It's Monday. Oh, catch up. You're behind. Okay. So what does this first branch of my tree represent happening over my 3-day period? Can you read that?
It rained all 3 days.
It rained, it rained, it rained. It rained all 3 days. To figure out the probability, what you do is you multiply all the probabilities together as you go out. So it'd be 0.2 times 0.2 times 0.2 to get the probability that it rained all 3 days. So 0.2 to the third power is what? Nope.
0.008.
0.008. Very unlikely. That's 8/1000ths of a chance that it's going to rain all 3 days in a row. All I did was multiply 0.2 times 0.2 times 0.2.
So is this what the weather people do?
Kind of. What does the second branch represent happening over my 3 days?
Rain, not rain.
It rained the first day, it rained the second day, but no rain the third day. So rain, rain, no rain. To get that probability, you've just got to multiply what's on the branches. So 0.2 times 0.2 times a 0.8.
0.032.
0.032. Thank you. What happened on this third branch? Rained? No rain. Rain. So rain, no rain, rain. It's still going to be the same as that one because it doesn't matter. It's 0.032. All right, the third or the fourth branch. What happened?
No rain, rain.
Nope, we're still up here. Rain, no rain, no rain. So it rained the first day, then no rain on day 2 or day 3. So this is going to be a new probability because I've got 0.2 times 0.8 times 0.8. Matt was doing that for us, but he got up to shut the door. And I don't have it written down.
0.128.
128. Okay. The next branch. What happened on the first day? No rain. Then the next day, rain and rain. So 2 rains and a no rain, that's 0.032. Is everybody following the tree where I'm getting this 3-part letter from? Okay, so this one is no rain, rain, no rain. So 2 N's and an R. That's 0.128. Our next one is no rain, rain on the third day, 0.128. No rain all 3 days is what? 0.512. Okay. Now that we've made the tree diagram, we want to make the probability distribution for the number of days that it rains. So a probability distribution lists all possible outcomes, and I am looking at the number of days that it rains. And then the probability of that happening, P for probability. And they usually call this number X, and then they say P of X, probability of X happening. So, how many days, what are all my possible options for how many days it could rain? 0 through all 3. So she said it could rain none of the days. It could rain 1, 2, or 3 days. Do you agree with that? Those are the only possible outcomes for the number of days it could rain. Now we want the probabilities. What branch or branches up here match no rain days? What's the probability that it doesn't rain on any of the 3 days?
0.512.
Yeah, this is the only spot where it doesn't rain on any of the 3 days.
Why are there 2 X's? Why is there X?
This,
Yeah.
and this is the probability of this happening.
Oh, okay.
So if X is 0, what's the probability that of 0 days of rain? So we got 0.512, over a 50% chance. Okay, the probability that it rains only on one day. How many times did that happen in my tree here? 1 day of rain. Where is it at?
3 zones.
It's here, it's here, and it's here. So it could rain on the first day and not the other two, or the second day, or the third day. So what I need to do to get the probability that it rains on one day is add those three things together. So it's 1.28 times 3, essentially. What's 1.28 times 3? Because there's 3 options for it only raining one day. Point what?
0.384.
0.384. You got to add those together. It's 0.128 multiplied by the 3 options that it came up. How about 2 days of rain? Where are those at?
0.032.
The 0.032. How many times did it rain just on 2 days? There, there, and there. So it's 0.032 multiplied by 3 of them. What does that come out? 0.096. And then what's the probability that it rains on all 3 days? How many times did that come up in my tree? Just the once. And what's the probability of that happening? 0.008. That's a probability distribution.
That helps us with
We're just starting.
weather. I don't understand.
Just hold on to those questions. Oh, I got right into the quizzes. I got to flip them over. Use the backs. Okay. So, what we just dealt with there, when we made this first column, now some definitions. When we made this first column of x values, the statisticians refer to that as a random variable. So, random variable. We got to get some vocabulary out of the way.
Wait, you say you were going to show us that shortcut now or no?
It's coming. X represents the value.
Is this a definition
Yep.
of random variable?
Of random variable. I don't know.
Gamma.
Represents the values assigned to the outcome of a probability experiment. So the experiment we just did was counting the number of days it rained. So our random variables were 0 days of rain, 1, 2, and 3. Those were our x values for the example we just got done doing. So x represents the possible outcomes. Okay, and what we just did is called a discrete random variable. A discrete random variable
For the random variable, is it probability experiment?
Yep. A discrete random variable has a finite, what's finite mean? Limited. You can count them. Number of outcomes. Here, just think my outcomes can only be whole numbers. That's how I pick between these two. Outcomes can only, I can spell only be whole numbers. Like our days of rain. You don't get 1.5 days of rain. It either rains or it doesn't. You count it as a rain day or you don't count it as a rain day. There's no in-betweens. If you can get in-between whole numbers, that's called a continuous random variable.
Please slow down.
Yep. continuous has an infinite number of possible outcomes. Here your outcomes don't have to be whole numbers. You can get fractions and decimals. Outcomes can have decimals. How's that? So let's get that down. All right, you ready? So I'm going to give you two situations. I want you to tell me whether it would be discrete or continuous.
Example 2.
Oh, two, you're correct. Continuous or discrete. Okay, we're going to record the number of home runs each season for the baseball and softball teams. Then the other thing we're going to do is record the time needed in minutes to finish the test for each person. Okay, and one of those situations is continuous and one is discrete. So all you've got to think is, which one of those outcomes can only be whole numbers? Which one could have decimals? So, right, can I get 5.5 home runs in a season? 6.5, 6.3?
You can average 5.5.
Average, we're not talking, we're just going to record the number of home runs made by the team each season. You can't get decimals there. You can only get 0, 5, 1, 2, whatever. So this is your discrete situation. The time needed to finish the test, can I get in between whole number minutes there? Could someone take 35.5 minutes?
Yeah.
56.8 minutes? That's your continuous one. So just think the outcomes. Could I get whole numbers? Can I only get whole numbers, or can I get decimals? That's how you tell the difference there. Okay. The two conditions for a probability distribution. Oh, we're only going to work with discrete probabilities, by the way. We're not going to do anything with continuous. You just have to know the difference between the two. So, a discrete probability
Is this concept like how long is it?
distribution. I'm going to fit it on the bottom of my paper here. Has two characteristics. Well, you know what it is. It lists the two columns, right? It's the two-column table. Of x values and probabilities. two things will be true about your table. Each probability will be between 0 and 1. That's our probability scale. Can a probability equal 0? Yep, it could, that means it's absolutely not going to happen. Can a probability equal 1? Yes, that's a 100% chance that's going to happen. So they could, I say between, but I mean also including 0 and 1. You just can't have any negative probabilities, and you can't have any probabilities over 1. Are we good there? And then the second thing, the sum of the probabilities will add up to 1. Ready for our next example? Okay. So, we want to, example 3, construct the probability distribution. Construct the probability distribution for this information. I'm going to give you a frequency distribution. So a company tracks the number of sales that new employees make each day during a 100-day probationary period. So you're on the job for 100 days. They're going to evaluate you at the end of the 100 days and see if they're going to keep you or let you go. So you're saying who would gather data? Any company is going to gather all kinds of data. That's just one small example. So the number of sales made each day, and then the frequency that happened. So we've got, they made anywhere from 0 sales in one day all the way through 7 sales in a day. What are they selling? I don't know. I'm kind of guessing shoes or something. I don't think it's cars. I don't think you can sell 7 cars in one day. Vacuum cleaners? That'd be tough too. I don't know. Let's see. So this, then this is the frequency. 16 days they made no sales. Then 19, 15, 21, 9, 10, 8, and 2. Okay, so that's the frequency distribution. We talked about those in the last chapter. We want to turn this into a probability distribution, which shows the number of possible outcomes. Well, that's already listed here. It's my sales. I can make 0 all the way through 7 sales. Well, I'll call that X. All I'm missing is the probability. What's the probability that these new people make no sales in a day? What's the probability they make 5 sales in a day? Based on their data. What do I have to do to figure that probability out? Total them up. Well, they told me this was a 100-day period. Are all of the distributions going to add up to 100? No, this one they did. If you were to add all of these up, this was over a 100-day period. But don't think they all add up to 100. So you will have to add those up. What do I do with that total to figure out the probability? Yeah, you just take each frequency and divide by the total. And you're basically doing relative frequency. Your relative frequency is the probability. So again, they don't all add up to nice numbers like this one does. Because, well, how do you divide by 100? Move it over 2 places. So it's a 16% probability, 0.16. Do I need to show all the dividing by 100 on the rest of these?
No.
No. 0.19. But just don't think they all add up to 100. Whatever the number is, that's what you divide by. There's your probability distribution. I think I'm going to go with 2 more things. Is it a probability distribution? If not, you got to tell me why it's not. I'm going to go horizontally so it doesn't take up as much space. Okay, for this probability distribution, the outcomes, I don't have any idea what it is, 5, 6, 7, and 8. One 16th, 5/8, 1/4, 1/8. It looks good. What do I need to check to see if it's a probability distribution? It has to add up to 1, and what else? Each probability has to be between 0 and 1. Are all of these between 0 and 1? Yep.
Yeah.
So that's good. Can you tell if they add up to 1? You could type it in on your calculator, or you could get them all a common denominator and add, but they got to add up to 1. If I do a common denominator, what's my common denominator? 16. I'll leave that one 1/16. This one I multiply by 2, I'd get 10/16. This will be 4/16. And this will be 2/16. What do they add up to? 17/16. That's over 100%. So is that a probability distribution? No. Somebody made a mistake somewhere. Not. Outcomes are 1, 2, 3, and 4. .09, 0.36, 0.49, let's see, I should have had this better. I'm going to change this one to 0.42. See if I got that right.
0.49.
Yep.
Is that negative .06?
Yes, it is. No, I still didn't get it right.
Is that a thing?
Well, no.
I wanted them to add up to 1, but not be. I just have to make that one more bigger. I just got to make 6. Oh, yeah. Let me make this 0.15. Then I think I'll have it. There it is. Okay. So, first of all, is it a probability distribution?
No.
Why not? Right. Isn't between 0 and 1. If you check, is each value between 0 and 1? Well, not this one. But if you were to check, do they add up to 1? They certainly do. So this condition's met, this one's not. But because this first one's not met, it's not a probability distribution.
Are you gonna fit yours or?
Yep, this is going to be it.
That's it?
Mm-hmm. Keep them simple. If I'm telling you that those are the only outcomes for X and those are the probabilities, I want you to finish by filling in that last probability and make it a probability distribution. What do you have to do to make this happen? Add all of them up, subtract from 1. Because these 4 values have to add up to 1 to be a probability distribution. So if you add them up, so it's going to be 1 minus 0.25 plus 0.15 plus 0.45. Did you get it? 20, 30, 70, 85, 15?
Yep.
So this needs to be a 0.15. Okay, I think I'm going to save this stuff for tomorrow. I think I'll save that for tomorrow. Okay, you get to do page. So, 159. 1 through 4. Constructing, let's go expected value. All right, we'll go 8 through 26 even. When you get to 24 and 26, you're not going to be able to do anything but, oh, you can't even do that. Oh, stopping at 22. Forget I said that. 22. We'll go there. It's very quick and easy. Quick and painless today. We'll get into the math stuff tomorrow.